Bismillahirrahmanirrahim. This lecture is about the internal energy or enthalpy. The main objective of this lecture is to understand the difference between the internal energy and the enthalpy. Or you can say that uh, the, the process, which is the isoporic process, or the process occurring at the constant volume, or the process at the constant pressure, and you call it the isobaric process. So actually in the previous video we have discussed in detail the first law of the thermodynamics and the pressure and the volume work, which is having the value of this work is equal to minus P delta V. And here delta E is the change in internal energy, and the Q represent the transfer of the heat, which may be having the sign positive when the system gains the heat, or it may be negative if the system loses the heat. And similar to the this explanation we have discussed in the previous lecture in detail. There are the two works, maybe the expansion or the contraction, but in here we are representing here the pressure volume work, and we have derived this relationship in the previous video. So this is the W is equal to minus P delta V. So actually delta E equal to Q plus W. This is the first law of the thermodynamics. And here I'm going to replace the work, and this work is the minus P delta V, and we call it the pressure and the volume work. So here Q is important because the heat transfer, we are going to discuss the heat transfer at constant volume and the heat transfer at the constant pressure, which are the isoporic and the isobaric process. So if you want to get the value of the Q, and the Q will be equal to this equation delta E plus P delta V, because here if you want to get the value of the Q, and you have to move this minus P delta V on the left side, and this will become the positive, and this Q will be equal to delta E plus P delta V. So now actually, as I have discussed in at the start of this lecture, that we are going to discuss the and to differentiate between the internal energy or the enthalpy, or you can say internal energy is the heat transfer at the constant volume, or the enthalpy is the heat transfer at the constant pressure. And this we are going to prove actually in this lecture. So the first is the what is the energy, or the this is the internal energy or the heat transfer at the constant volume, and this actually this process is called the isoporic process. So what again, this is the same equation we have discussed in the previous slide, but what we are going to do over here, the heat transfer at constant volume. That means when the volume is constant, that means change in volume will be equal to zero. So when the change in volume will be equal to zero, that means there is no pressure volume work. So remember, this is the work. So when the change in volume is zero, when you multiply zero with the P, again this factor will be equal to zero. That means there is no pressure volume work is done on the system. And the heat or the energy change of the system, this is the energy change of the system, is entirely due to the heat transfer, and which we are going to write over here. This heat transfer is at constant volume, that will be equal to delta E, because this has become zero due to the change in volume. and Q will be equal to delta E. But here the Q, when this is equal to delta E, and there is only one option when the change in volume is zero. That's why we have written over here QV, and this is representing the heat transfer at constant volume. That will be equal to the change in the internal energy. So if I ask what would be the change in internal energy, and that means this is the heat transfer at the constant volume, or when there is the heat transfer at constant volume, you can call it there is no pressure volume work. That means the system is having only the change in the internal energy. So this is about the change in the internal energy, and this is at the constant volume. You call it the isochoric process. So there are the three different words we can use. What would be the isochoric process, the heat transfer or the change in internal energy of the isochoric process, or the heat transfer at the constant volume, and the net or the final conclusion is the heat transfer at constant volume will be equal to the change in the internal energy. Now, what would be the enthalpy? So, enthalpy is the heat transfer at constant pressure, and you call it the isobaric process. And again, remember we have already discussed in the thermodynamic process in detail what are the isobaric or the isochronic or the other process over there. So what we are going to discuss here again, what is the change in the enthalpy, and here this is at the constant pressure. That means there is no change in volume is not equal to the zero. So when actually if you carry out the reaction in the open flask or other apparatus that keep the pressure constant and allows the volume of the system to change freely, so in this case change in volume will not be equal to zero, and the change the energy change or change in energy of the system might be due to the both heat transfer and the work done, because this is at the constant pressure. That means again the isobaric process is the they should not be change in pressure. That means it is at the constant pressure. This delta P may be equal to zero, but P, the pressure is not equal to zero. So here, this is very important to understand. It is at the constant pressure. That means pressure is having some value, and there may be the heat transfer. So this the change in volume will not be equal to zero. That means the work is not equal to zero, as we have discussed one of the case in the previous slide. So this is not equal to zero, and this is also not equal to the zero. That means the heat transfer in the system might be due to the both it is the heat transfer and the pressure volume work. So that would be equal to the this statement. So because reactions carried out at the constant pressure, so common in chemistry, the heat change for such a process is given by a special symbol that is called the delta H, and this is called the heat of the reaction or the enthalpy change of the reaction. And this enthalpy change of a system is given, the name is given to the quantity. That means this is the E plus PV. That this is the actually the equation. That means change in enthalpy will be equal to delta E plus P delta V, and this is as written over here. So that means the heat transfer at constant pressure will be equal to this, and this is equal to the delta H, So delta Q will be equal to the delta H. So you can say that the uh, change in enthalpy or the heat transfer at constant pressure or in isobaric process, the change in heat is actually the heat transfer at the constant pressure. So if you want to calculate the change in enthalpy, so this is the actually the enthalpy of the product minus enthalpy of the reactant. You can calculate the change in enthalpy. So but again, the important thing to keep in mind that this change in enthalpy is at the constant pressure, and the change in internal energy is the heat transfer at the constant volume. So whenever there is the heat transfer at constant volume, that is the internal energy. Whenever the heat transfer at constant pressure, this is called the change in the enthalpy. So this is an example to differentiate uh, between the delta E and the delta H, the change in internal energy or the change in enthalpy. And again, this is the heat transfer at constant volume, this is the heat transfer at the constant pressure. So this is an example. This is the propane is going to react with the oxygen, forming the carbon dioxide and the water. So actually 1 mole of propane, 5 mole of oxygen, so there are the 6 moles on the reactant side, forming 7 moles on the product side. So this is a little bit the expansion is being happened over here. So actually the change in internal energy is having a value of minus 2045 kilojoule, and the change in enthalpy is having minus 2043 kilojoule. So the difference is the 2 kilojoule, as this is the again equation. If you want to calculate, you can also calculate by using this equation as we have discussed before. So delta H will be equal to delta E plus P delta V. So here the values are given over here. So if you want to get the value of P delta V, that means you have to move this on the right hand side, and this will become delta H minus delta E. So delta H is given over here minus, and this is the minus. When you minus multiply with minus, this will become positive. So again, when you take the difference between these two, you will get the value of the 2 kilojoule, the difference between these two values. So actually, this is giving you the indication that there is the small amount of the expansion work is done against the atmosphere, as there is the 6 moles of the gaseous reactants are converted into the 7 moles of the gaseous product. So actually, this is going to show you that the difference between delta H and delta E is usually small. So the two quantities are nearly equal. So because the two is not a big difference if you compare the values, total values of the delta E and delta H, which are in thousands. So this two is the insignificant. So that's why the chemists usually measure and speak about the change in enthalpy, though, because most reactions are carried out at the constant atmospheric pressure in loosely converted vessels. So that's why it is a common practice we use the term delta H instead of the delta E. So this is the actually the difference between these two uh, thermodynamics parameter.